The German engineer traced his hand along the exterior of the American tank. Something was incorrect. Not incorrect with the tank, incorrect with everything he had been informed about American production. It was April 1943. The tank positioned in the Kummersdorf proving grounds had been seized in Tunisia 2 months earlier. Serial number USA 306-7641. The Americans had designated it War Daddy 2. German High Command desired a thorough assessment. They desired to understand the Sherman's vulnerabilities. They desired firing charts displaying precisely where to strike it. The engineer had invested 3 weeks inspecting every element, and what he discovered wasn't vulnerability. He traced his fingers over the welds. They weren't just powerful. They were pristine, consistent, machine-produced. It wasn't just a production philosophy that frightened him. It was the understanding that while Germany was constructing masterpieces, America was manufacturing tanks. War Daddy 2 had been seized on February 22nd, 1943, 8 days after the Battle of Sidi commenced. That battle was a catastrophe for the Americans. German panzers had crashed into the 1st Armored Division and sent them retreating back toward Kasserine Pass. The tank belonged to Company G, 3rd Battalion, 1st Armored Regiment. During the disorder of the withdrawal, the crew had deserted it. Perhaps they exhausted their fuel. Perhaps they sustained a strike that immobilized the track. The records don't indicate. What the records do indicate is that German recovery teams discovered the Sherman undamaged. And unlike most seized tanks, this one ignited on the first attempt. The Germans operated it over 200 miles to Tunis, 4.5 days across the wasteland. No malfunctions, no mechanical failures. They transported it onto a vessel and dispatched it to Germany. High Command desired their finest engineers to dismantle it. What those engineers discovered would transform how they comprehended the war. Kummersdorf was Germany's premier weapons evaluation facility. Positioned 20 miles south of Berlin, it had been the birthplace of the German rocket program and the evaluation ground for every major Wehrmacht weapon system. The finest engineers in the Reich labored there. They had assessed captured Soviet T-34s in 1941 and assisted designing the Panther as a response. Now they possessed their first American medium tank. Initial anticipations were minimal. German intelligence had dismissed the Sherman as a mass-manufactured, inferior design. Thin armor, weak gun, constructed by a nation that had never engaged in a modern tank war. The engineers approached the Sherman with the arrogance of craftsmen inspecting a cheap imitation. They anticipated sloppy welds. They anticipated brittle steel. They desired to ridicule the crude American attempt to construct a war machine. They had their pens prepared to compose a scathing report that would make High Command pleased. They commenced with the armor, measured every plate, calculated every angle, stenciled the numbers directly onto the exterior in white paint. The armor thickness was adequate, but not remarkable. 51 millimeters on the front hull, 38 millimeters on the sides. A tiger could penetrate through it at over a mile. Then they opened the engine compartment. The Continental R 975 radial engine sat in the rear of the hull like an aircraft engine that had been inserted into a tank. Because that's precisely what it was. The Americans had taken a proven aircraft power plant and modified it for armored utilization. 400 horsepower, air-cooled, designed for reliability at altitude where mechanics couldn't access it. German engineers noted the power-to-weight ratio immediately. The Sherman weighed 30 tons. The engine provided it 13 horsepower per ton. The Panther weighed 45 tons with a 700 horsepower engine, only 15.5 horsepower per ton, barely more than the smaller American tank, despite weighing 50% more. But power wasn't what impressed them. Any nation could construct a powerful engine. What impressed them was the maintenance accessibility. Every major component could be accessed through large hatches. Oil changes required minutes. Spark plug replacement demanded no special tools. A mechanic with basic training could maintain this engine operating indefinitely. German tank engines demanded factory-trained specialists for routine maintenance. The Maybach HL230 in the Panther had known cooling challenges that caused engine fires. Replacing one demanded a crane and a full day's labor. The Americans had constructed a tank that could be serviced in the field by anyone. The Germans had constructed tanks that needed to be transported back to factories. The engineers kept examining, and it kept deteriorating. It was the sound that halted them. or rather the absence of it. When they operated the powertrain, the German engineers were accustomed to the screaming whine of spur gears battling against friction. The Sherman hummed. One engineer called his colleagues over, unable to believe what he was hearing. Herringbone gears, precision-cut helical teeth that meshed smoothly under load, the kind of gears that lasted for thousands of miles without deteriorating. German tanks utilized spur gears, straight-cut teeth that were cheaper to manufacture, but deteriorated quickly under the stress of combat driving. The reason was straightforward. Herringbone gears demanded complex machining and specialized gear cutting tools that Germany lacked. The tooling utilized tungsten carbide, a strategic material in short supply due to Allied blockades. Germany reverted to spur gears to conserve manufacturing time and reduce tooling wear. The Sherman's transmission could handle 3,000 miles before needing an overhaul. The Panther's final drive had an average lifespan of around 100 miles, not 100,000, just 100. A Sherman could drive from Normandy to Berlin under its own power. A Panther could barely manage it from the rail yard to the front lines. The engineers documented everything, but they weren't prepared for what arrived next. The 75 gun had a small box attached to its mounting. Electrical cables ran from it to a gyroscope near the gunner's position, a gun stabilizer. The Americans had installed a gyroscopic stabilization system in a mass-manufactured tank. German engineers were astounded. They had experimented with stabilizers, but never managed to miniaturize the components enough for tank utilization. The precision demanded was beyond their manufacturing capabilities. The Westinghouse system wasn't perfect. It only stabilized in the vertical plane. It didn't allow true shoot-on-the-move accuracy in the modern sense, but it accomplished something far more valuable. It maintained the gun roughly on target while the tank moved, which meant the gunner could fire accurately within seconds of stopping. German tanks needed 10 to 15 seconds for their suspensions to settle before the gunner could aim properly. In a tank duel, the first accurate shot usually won. The Sherman could deliver that shot before a German tank had even stopped bouncing. The Germans examined the gyroscope and servo motors. They calculated what it would require to replicate the system. The answer was that they couldn't, not with their current industrial base, not with the materials available, not with the precision manufacturing they possessed. And they still hadn't discovered the worst part. In June 1943, War Daddy 2 was transferred to Hillersleben for a demonstration before the High Command. They didn't desire a reliability test. They desired a show. Senior officers from across the Wehrmacht gathered to observe. Generals who controlled armored production priorities, men who would determine whether to keep constructing Tigers and Panthers or change course. They established a climbing test, a steep 30-degree slope of loose sand. The Panther went first. The German tank roared up the hill effortlessly. Its wide tracks bit into the sand. Its powerful engine never strained. The generals smiled. Then came War Daddy 2. Its narrower rubber block tracks, designed for road marching, slipped on the loose surface. The engine whined. The tracks spun. The tank slid backward. The Sherman failed to climb the hill. The generals applauded. The demonstration had proven precisely what they desired to believe. The failure on the hill at Hillersleben was a catastrophe, but not for the Americans. It was a catastrophe for the Germans. The generals examined the hill and perceived a victory. The engineers examined the transmission and perceived a warning. The Panther had won the sprint, but the engineers understood it would never survive the marathon. While the Sherman couldn't climb that specific sandy slope, it had just driven over 200 miles across the Tunisian desert under its own power, a feat the Panther could rarely match without breaking a final drive. The hill climb validated every incorrect instinct the German military possessed. It convinced them to keep constructing high-performance thoroughbreds instead of reliable workhorses. The engineers who had invested weeks inside War Daddy 2's engine compartment understood the truth, but they had just observed their generals cheer as the Sherman slid backward on loose sand. Nobody desired to hear that the American tank's failure on the hill meant nothing compared to its success reaching the hill in the first place. And then Albert Speer arrived to observe for himself. Albert Speer was the Reich Minister of Armaments. He controlled German war production. Every tank, aircraft, and submarine constructed in Germany came under his authority. Speer had a reputation for efficiency. He had tripled German weapons production in 1942 through reorganization and streamlining. He believed German engineering could outproduce the Allies if properly managed. Photographs exist of Speer examining War Daddy 2. He studied the reports, he conversed with the engineers, and he reached a conclusion that would haunt him for the rest of his existence. Speer later wrote in his memoir that reports from Italy praised the Sherman's cross-country mobility. The American tank climbed mountains that German experts considered inaccessible to armor. The engine's power-to-weight ratio provided it superior mobility on level ground compared to German designs. But Speer comprehended the deeper problem. Germany was constructing complex machines that demanded a dedicated rail network to move. America was constructing a mobile force that could drive itself to the front line. Speer realized that no amount of German engineering genius could overcome a logistical philosophy that was simply superior. The Sherman wasn't just a tank, it was a philosophy. American industrial philosophy prioritized three things: reliability, maintainability, mass production. German industrial philosophy prioritized one thing: technical superiority. American designers had made different choices. They accepted a less powerful gun because the 75mm was reliable and ammunition was plentiful. They accepted thinner armor because it reduced weight and improved mobility. They accepted a simpler design because it meant faster production and easier maintenance. Germany couldn't compete with that, not because German engineers weren't brilliant, because German engineers had optimized for the incorrect things. The men who comprehended this best weren't engineers, they were tank crews. Alfred Rubbel commanded a Tiger Eye in the 503rd Heavy Panzer Battalion. He eventually became an ace with 57 confirmed kills. He understood precisely what German tanks could and couldn't accomplish. His unit utilized captured Shermans for recovery and supply duties. Rubbel later compared the Sherman to a reliable civilian car. You push the button and they ignited. With the Tiger, there was always a procedure: checking fluids, warming up, worrying about the transmission. The Sherman just functioned. German tank crews loved their Tigers and Panthers when they functioned. The problem was they rarely functioned. By 1944, German armored divisions reported operational readiness rates of 35 to 45%. More than half their tanks were broken down at any given time. American armored units maintained readiness rates above 85%. When they needed tanks for an offensive, they possessed tanks. The numbers communicated the story that German propaganda tried to conceal. The Normandy campaign proved everything the Kummersdorf engineers had feared. During the retreat from Normandy, roughly half of all abandoned Panther tanks had been destroyed by their own crews after mechanical breakdowns. Not combat damage, mechanical failure. Imagine the frustration of a German panzer crew. You possess the most powerful gun on the battlefield. You possess the thickest armor. But you're standing on the side of a road in France, observing your transmission smoke, while a column of inferior Shermans drives past you to win the war. They didn't lose because they were outfought. They lost because they couldn't even reach the fight. The statistics from the Battle of the Bulge were worse. By late 1944, 60 to 70% of German heavy tank losses were non-combat related. Fuel shortages and breakdowns, not American gunfire. The engineers at Kummersdorf had perceived this approaching in April 1943. They had attempted to look past the showy hill-climbing demonstration at Hillersleben and concentrate on what actually mattered: the internal components, the manufacturing philosophy, the brutal mathematics of reliability. They had documented every advantage the Sherman offered. They had written reports explaining precisely why American mass production would win the logistics war. Nobody had listened. The generals had observed the Sherman fail on a sandy slope and walked away confident that German engineering was superior. Germany couldn't adopt American manufacturing philosophy for reasons that went beyond engineering. The strategic materials weren't available. Herringbone gears demanded complex tooling that Germany lacked. Precision electronics demanded copper and rare earth elements. Allied blockades had cut Germany off from global supply chains. The production culture couldn't change fast enough. German factories were organized around skilled craftsmen who hand-fitted components. American factories utilized interchangeable parts and assembly lines. Converting one system to the other would require years Germany didn't possess. The Nazi ideology got in the way. German engineering was supposed to be superior. Admitting that American mass production techniques were superior contradicted everything the regime believed about Aryan technical superiority. So Germany kept constructing Tigers and Panthers, magnificent machines that invested more time broken down than fighting. Technical marvels that couldn't compete with American quantity and reliability. Germany remained trapped bound by an ideology that demanded perfection and an industrial base that could no longer afford it. The final numbers: America constructed 49,324 Sherman tanks during the war. Germany constructed approximately 6,000 Panthers and 1,347 Tigers. The production ratio was nearly 8-1 for medium tanks alone, and American tanks actually functioned when they reached the front. A Tiger could destroy 5 Shermans in a single engagement, but there would be 6 more Shermans arriving tomorrow, and the Tiger would be broken down, waiting for a transmission that wouldn't arrive for 3 weeks. The mathematics were brutal. German tankers achieved kill ratios that would have won any other war. But this war wasn't about kill ratios. It was about logistics. War Daddy 2 had demonstrated the German engineers precisely why they would lose: a tank that ignited when you pushed the button, a transmission that lasted the life of the tank, an engine that any mechanic could service. Reliability beats perfection. Availability beats capability. Working beats superior every single time.